This meeting is being recorded.
For problem 9 in chapter 21, we are asked here to identify the reagents that can be used to accomplish each of these transformations. So we see here in part A that we go from this cyclic secondary alcohol to this alpha beta unsaturated ketone here in our product. So let's make note of that. And how can we accomplish this transformation? So we can see that through a three-step mechanism here, we can transform that secondary alcohol in the first step to a ketone using strong oxidizing reagents such as sodium dichromate here. And we know that we need to generate chromic acid, so we'll have sulfuric and water as well. So using, again, this chromic acid oxidative reagent here, we could generate the ketone seen as an intermediate here. Then we can treat that ketone, as we saw in this chapter, with bromine, Br2, in acidic conditions. And what happens there is that we will brominate our alpha position here. So I did not draw the mechanism out, but note that this is in the alpha position. We brominate, and then using, I'm going to just abbreviate pyridine here, PY, we're going to eliminate, so we'll kick out that that bromine there as a leaving group. We will remove this proton here, and those electrons will form the pi bond seen in our product, our alpha beta unsaturated ketone. So again, our last reagent is pyridine. All right, let's take a look at part B here. So now instead of a secondary cyclic alcohol, we start with a primary alcohol. We can convert that in one step here, in the first step here, to an aldehyde intermediate by using a few different reagents. So we could use the pyridinium chlorochromate. We could also use the Des-Martin DMP, or we could do even a Swern SWERN, there we go, Swern oxidation as well. Any of these will generate this aldehyde intermediate. So whether or not you see, in this case, say PCC with a dichloromethane. Right, so we could see CH2Cl2. So we'll utilize this in our mechanism as our first step to generate that aldehyde. Then, just like we saw in part A, in acidic conditions, we can brominate using Br2, our alpha position, which will be right here. And that's what we see with this bromine installed in our second intermediate here. Then utilizing pyridine, so we'll have PY here again, or rather up here, pyridine as our base. We can deprotonate our intermediate, and then we'll grab, let's say, this proton here. That would, once deprotonated with pyridine, that would form the pi bond seen in our product here. And that also facilitates the leaving group bromine.